Welcome to Centum. Okay, so today we discuss chapter 1 from class 12 NCERT, that is relations and functions. Okay, so what is relation? It is the connection between the elements in the set. Okay, for example, this is a set and these are the elements. So what is the connection between the elements gives what is relation. Okay, there are three types of relation: reflexive, symmetric and transitive. So we will come to this. And function. Okay, function is a relation between the set. Okay, so A is a given set and 1 to 14 are the elements. What is the function given? 3x minus y equal to 0. So this is the function. Fine. Okay, so we have three types of relation. Okay, one is reflexive. Okay, for example, if x belongs to R, then for each and every input we should get the same output. Okay, so if we give 2 as the input, we should get 2 as the output. Output is also called as image. Okay, if we give minus 3 as the input, we should get minus 3 as an output. If this condition is satisfied, then the function is reflexive. Then symmetric. For the value of x, we are getting the value y. For input of x, we are getting the output of y. Then we should get, for the input of y, the output should be x. If this condition is satisfied, then the function is symmetric. The third one is transitive. Okay, for the input of x, we are getting the image or output as y. For the input of y, we are getting the output as z. Then for the input of x, we should get the output z. If this condition is satisfied, okay, then the function is transitive. Okay, so we come to the first exercise, first question. Okay, so determine whether each of the relations are reflexive, symmetric and transitive. Okay, so the first already, first Roman relation R in the set A equal to 1 2 up to 14 defined as R equal to x comma y such that 3x minus y equal to 0. Okay, so we will check. So we will check for reflexive first. So what is reflexive? For each input, we should get the same output. Okay, we will take any value from this. Okay, for example, 2. We will take x equal to 2. Okay, substitute in the given function. 3 into 2 minus y equal to 0. 6 minus y equal to 0. So y equal to 6. Therefore, 2 comma 2 does not belong to the R. Or x comma x does not belong to R. Therefore, this is not, the function is not reflexive. Okay, so this is not reflexive. Okay, so let's check for symmetric. Okay, so what is symmetric? For the input of x, we are getting y, and for the input of y, we should get x. Okay, so again take a value x equal to 3. Okay, so what is y? 3 into 3 minus y equal to 0. So 9 minus y equal to 0. So y equal to 9. So for 3, we are getting image 9. So for the image 9, we should get 3, right? Let's check. So 3 into 9 minus 3 into 9 minus y equal to 0. 27 minus y equal to 0. Y equal to 27. So y is not belonging to R, and also 9 comma 3. So 9 comma 3 does not belonging to R. Therefore, this is not symmetric. So now we check for the transitive. Okay, so what is transitive? Okay, so for example, let x equal to 1. So 3 into 1 minus y equal to 0. 3 minus y equal to 0. So y equal to 3. So for the input of 1, we are getting output 3. Okay. Okay, then for the input of 3, right? For x equal to 3, okay, so 3 into 3 minus y equal to 0, 9 minus y equal to 0, y equal to 9. So for the input of 3 we are getting 9. Then for the input of 1 we should get 9. Will it be possible? No, because for the input of 1 we will get 3 only. So 1 comma 9 not belonging to R, therefore this is not transitive. Okay, so coming to second problem, the relation is given as x comma y such that y equals x plus 5 where x less than 4 and the domain is natural numbers. Okay, so first let's check for reflexive. Okay, so what are the possible values of x? So x should be 1, 2, 3. Okay, so for example x equal to 1, y is equal to 1 plus 5, 6, right? So 1 comma 1 does not belong into the R, therefore this is not reflexive. Let's check for symmetric. Okay, so we will take x equal to 2. So for x equal to 2, y equal to 7. Then for x equal to 7, we should get y equal to 2. Okay. Now for x equal to 7, y is equal to 12, right? Therefore x comma y comma y comma s does not belong into R. 2 comma 7 comma 7 comma 2 does not belong into R. So this is not symmetry. Okay, so now we check for transitive. Okay, so we will take x equal to 3. So for x equal to 3, so y is 8. Okay, so 3 comma 8. Then for x equal to 8, then y is equal to 13, right? Then for x equal to 3, we should get 13, right? But for x equal to 3, y equal to 8. Therefore, this is not transitive. So third question, what is given? Relation R in the set A equals 1, 2, 3, 4, 5, 6 defined as x comma y such that y is divisible by x. That is, if you write x comma y, which means second number is divisible by the first number. Okay, so let's check for reflexive. Okay, so take any number in the domain, for example 3, okay, comma 3. So the second number is divisible by the first number, right? 3 is divisible by 3. Therefore, this is reflexive. Okay, so we will check for symmetric. Okay, so for example, we will take 1 comma 3. Okay, so 3 is divisible by 1. Okay, so this belongs to R. So if we write 3 comma 1, then 1 is not divisible by 3. Okay, so therefore this is not symmetric. Okay, so now let's check for transitive. Okay. Okay, so let's take 1 comma 2. Yeah, second number is divisible by first number. 2 is divisible by 1. Then we take 2 comma 4. Okay, then 4 is divisible by first number 2. Then 1 comma 4. Okay, again 4 is divisible by 1. Therefore, this is transitive. In the fourth Roman, relation R in the set Z of all integers defined as R equals x comma y such that x minus y is an integer. Okay, so first let's check for reflexive. Okay, so all integers, so we can take any whole number or its negative. Okay, so take minus 3. Okay, so minus 3, okay, minus of minus 3 equal minus 3 plus 3 equal to 0. Okay, so 0 is an integer, right? Therefore, this is reflexive. Let's check for symmetric. Okay, so for example 2 comma 5. Okay, so 2 minus 5 equal to minus 3 is an integer. Okay, so for 5 comma 2, 5 minus 2 equal to 3, it is also an integer. Okay, therefore this is symmetric. Right. So let's check for transitive. Okay. Okay. So we take 5 comma 10. Okay. So 5 minus 10 equal to minus 5. Minus 5 is an integer. Okay. Then 10 comma 20. Okay. So x minus y. 10 minus 20 is equal to minus 10. It is also an integer. Then 5 comma 20. Okay, so 5 minus 20 equals minus 15. It is also an integer. Therefore this function is transitive. Therefore this is transitive. Okay, so if a function is reflexive, symmetric and transitive, it is called as equivalence relation.